Okay, so this is classifying quadrilaterals on the coordinate plane with Anthony Hoang. So here we're given 4 points on the coordinate plane. So first, for the quadrilateral, to classify the quadrilateral on the coordinate plane, first we need to graph quadrilateral. So we're given points A on 4, 1, point A, and then point B is on 1, 3, here. Point C is on -4, 2, here. And point D is on 2, -2, D. Next, what I'm going to do is just graph the lines. Very, not going to be good lines, of course. But there are the lines. Okay, so next what you're going to do is check if any of the lines are parallel. So just looking at my drawing, CD over here, see this line CD and this line BA looks to be about parallel, but since it's a math problem, we can't just trust our eyes. We got to calculate stuff. So what we're going to do is use rise over run to check the slopes of these lines and see if they're parallel. So line CD, we're going to go from line C to line D. We're going to go this way. So the run goes from -4 to 2. The distance here from -4 to -2 to 2 is 6. So the run, it's rise over run. So that means that we have a run of 6, positive 6, and then the rise from C to D is from 2 to -2. So that means that the rise is -4. The slope of CD comes out to, if we simplify -4 over 6, it would be -2 over 3. And then we're going to check the other line. Just do the same thing. Rise over run. So we can see that from B to A, it's the run is 1. Goes from 1 to A, which is at 4, which means that the run is 4 minus 1, which is 3, and then the rise, so we can see that B is at 3, and A is at 1, so we see that it goes from 3 to 1, and 3 minus 1, 1. Yes, 3 minus 1 is 2. Oh, yeah, so that means that, for the run, 1 goes to 4, right? So 1 minus 4 is -3. Wait. Yes, so we just subtract from whichever one we choose first. So we're going from B to A, so we need to subtract the 1 minus 4, which is -3, and then the rise, which is 3 minus 1, which is 2, which gives us our slope, because it's already simplified. So then we can see that the slope of line CD, right here, -2 over 3, is the same as the rise of BA, which is -2 over 3. We have one pair of parallel sides. That means we can rule out that it's at least one of these. It could still be any of these, I guess. So then we have to check the last side. We have to check the whether or not the last sides are parallel. So we're going to go for this side and this side now. CB, right? We go from -4 to 1. That means this distance is, what is it? The run is 5, because we go to the right 5, a distance of 5. So that's the run. And then the rise, right here for CB, and then we go from 2 to 3, which means it goes up 1. The rise is 1. That means the slope of CB is 1/5. This is the slope for CB. And then for the last line, DA, right here, we get the slope. The distance from the run for DA is 2, 4. This is 2. And then the rise is right here, -2. It goes from -2 to 1. That means the rise is 3. So this slope, it would be 3 over 2 because rise over run. And that means we can see that these two sides are not parallel, which means we only have one pair of parallel sides. That rules out a square, which is has two pairs of parallel sides, rhombus, which also has two pairs of parallel sides, same for rectangle and parallelogram, which leaves us with trapezoid, giving us our answer.